All right. So without further ado, let's get started. Can it?
Sorry, am I lagging to you guys right now?
No, it seems all right.
Okay. So welcome everybody. This is going to be our Advanced CAD Practices workshop. We're going to be going over a bunch of things today. Just a lot of good design tips and tricks to help you guys, carry it towards your Solidworks when you design for X1 or for whatever purposes you may have. We'll be going over, assembly practices, whatever parametric design is, if you don't know what it is. And we will be giving a demo at the end. So it'll be a lot more hands-on than a usual presentation. And yeah.
All right. So starting right off, I want to discuss, in my own words and opinion, what makes good CAD, because I'm pretty sure everyone in here has probably done CAD of some kind before. And it's very easy to get into it a little bit and then get lost by the whole process and how best to streamline that process. And it can be a really frustrating process. So what I like to stress is that CAD is a tool to visualize and streamline your design, but it's not your entire design process. There's a lot more that goes into it than just making your model in CAD. So not everything you can CAD can be built to function, which means that things can have a lot of contradictions and conflicts in between. And you have to basically think about all stages of things. Another thing is that CAD as a team process can be difficult and requires a little bit more planning to do it in a team than doing it on your own. So good CAD for a team is going to have a couple of points, which is easily editable if you want to change something later, well organized in terms of how you've built things, smartly built, which hopefully we'll learn a little bit about that today, and as simply built as possible is usually a good rule. If you have to make a bunch of different operations to make a shape that you could make in 2 operations, you probably want to do that.
All right. So when you begin CADing, here's some things to keep in mind. A lot of us think that CAD is a tool just for visualizing your design, and it is a really good tool for that. But it goes both ways. Sometimes you want to have an idea in mind before you CAD it. So we stress that you would sketch your design before you start CAD, thinking about how it would look from different views before you even start modeling it in SolidWorks or Fusion 360 or something. You could be surprised at how many insightful things a sketch would give you before you even waste time on modeling. You should also always think about stress distributions. For example, if you have sharp corners, it's always best practice to fill it whenever you can. Thinking about the weakest part of a part or assembly can really guide how you design so that things don't break, and you need to do less testing to know what would break. I think the most important thing is to be able to design things to be accessible. Modular designs are really helpful in an assembly. For example, if you had a robotic arm that had 5 fingers, and if you wanted to fix the pinky, it'd be a lot more helpful to just fix the pinky and take it off individually, as opposed to taking off all 5 fingers beforehand. To achieve this, you design with screws and fasteners instead of permanent, I guess, fixtures like gluing or welding. And you design with slots instead of holes. So you could adjust your part whenever you can. Yeah. You should always think about the manufacturing process when you're designing. What material you're making it out of, whether you're going to mill it, lathe it, 3D print it. There's a lot of different things you could do with different manufacturing processes. So having a good idea of how you're going to build a part and manufacture it can kind of guide and give you different limitations when you design. Also, as I said before, you should think about the assembly process. So obviously avoid geometrical issues so things don't interfere with each other. And think about thinking the order of assemblies to sub-assemblies. So you could kind of break down a system into different parts. And once you have a design, what you can do is think about ways you could simplify it. Oftentimes a simple design's often the best design if you could achieve the same functions. And as always, you're never going to get a perfect CAD right off the bat. You're going to need to do different drafts of parts. So you could see, whether you see in CAD itself or when you do FEA, you're going to need to go through different revisions to perfect the CAD. And sometimes it's easier to just start from scratch rather than go through the effort of fixing all small problems of a part.
So moving forward with things to think about, once you're actually inside of your CAD software and you're starting to work with it, it helps if you start by optimizing your workflow. We're going to go over a couple of ways to do that. And it mostly involves setting up shortcuts. SolidWorks has a lot of helpful tools to do shortcuts so that you can move your mouse across the screen a lot less, basically. So you're not endlessly clicking into menus to get things. You can have all the tools that you need where they are. Design things to be easily editable. I mentioned this earlier, and we're going to go over it more. There's different ways to do this. There's different ways to edit designs once you have them. What I like to say is, if you can use a sketch relation, then if you can't do that, or if you need more complexity than that, then use an equation. And if that doesn't work, then you can use a dimension. But you shouldn't go right in and start dimensioning every single part or every single dimension in your model. Because a lot of times that's not so easy to edit without going way, way deep into your model every time. And we'll go over that more. Another good tip is decide what are the important parts of your design. Decide what you need to add and what you don't necessarily need to add. I do this a lot because SolidWorks is very slow on my computer. Don't add the tiny little features that are not helpful. Like, don't add threads to holes, even if they have threads in them, because that's a lot of geometry for the software to load. And if you know the thread is there, having it in CAD isn't really helping you too much. The same can go for like colors and textures and stuff. If you're into that, I generally skip it entirely. And the last point is use GrabCAD, as we've discussed earlier, to save your versions correctly. It'll help not writing over a bunch of your work or losing your work. If you need more help on that, you can review the video of our last workshop.
All right. As I've said before, it's really good for you guys to design subsystems to be easily disassembled. You never want to go through a lot of trouble to fix one part when you could have just taken it out from the start. And I guess another good assembly practice would be to think in planes. Basically, if in SolidWorks at least, you could, once you start a assembly and import a part, it'll be fixed. I try to minimize as much as I can how many fixed parts I have in an assembly. Because if you think in planes, then you could use features like mirror or linear pattern, or a lot of different features that would rely on planes that you wouldn't have access to if you didn't align a origin of your part to the origin of the assembly. Also, when I say think in planes, also think about when you're designing a part, whether you should sketch on the front, top, or right plane, just so that you're consistent when designing an assembly. Also, in an assembly, I'd advise you guys to never use suppress, and if you guys do end up using it, to minimize the use of suppress. Basically, what suppressing is if you have a mate, you could suppress it so that it doesn't register. But sometimes when SolidWorks rebuilds an assembly, it doesn't suppress all of its mates. So then this would lead to it being overdefined, and it just created a giant mess in an assembly with overdefined mates.
Okay, so parametric design was mentioned earlier. Parametric design is basically the idea of designing with parameters that can be easily changed. So a way to think about that is dimensions. You can define a dimension when you do a sketch or when you do a feature, and you can go in and change it later. But parametric design tries to, as much as possible, take those dimensions outside of the sketch where they're created. So usually what that looks like is the equations tab in Solidworks, which is a little bit tricky, but if you're patient with it, it can be really rewarding. What it allows you to do is define your dimensions and give them names in the equations tab, and they become global variables, and you can change them, and it will automatically update what your design looks like by changing its dimensions without going into each individual part that uses that dimension and editing it. So it can save you a ton of time if that's something that your design needs. So that's the main way to design parametrically. Another thing is CADing through features and not sketches. There are tools in SolidWorks that are going to make it so much easier to duplicate and pattern and help you make features. Hole Wizard is a great one because it creates holes to specifications automatically. It's very easy to change them. Also making patterns, mirroring things, that kind of thing. Basically, any place where you define a sketch or part of a sketch in relation to something else instead of defining it on its own is really helpful.
All right. So when you design, you should design from the top down. So that's what we mean by design intent comes from the top. When you design a part in an assembly, usually you'd want to take into mind other parts in the assembly so you could design for or around those parts. And these parts can be edited individually or in the assembly itself, in the context of the assembly. And this makes sense for some parts and not others. There might be some parts that you don't want to base it off another part in the assembly. Say like you have a main part. But for most parts, you'd have to keep in mind how it works with other parts in an assembly. So simple parts should not be top down. It should be bottom up because you don't need to worry about it interfering with anything else. And parts that have to, I guess, interact with other parts should be top down. For example, in the bottom left picture, that highlighted part, its shape is derived from that gold piece.
Okay, so here's a little bit more technical how you would do this in SolidWorks. So the two most popular or easiest ways to do it is either creating a part inside an assembly or editing a part inside an assembly. When you create a part inside assembly, it's a very easy option to just go to insert components and add a new part instead of importing an existing part. What that does is it creates what's called a virtual part. So it can be edited inside the assembly as if it was its own part file, but it's saved entirely within that assembly. It doesn't have an external file it's linked to. And that's really convenient because you can delete it, you can move it around, you can rename it, you can change it, and SolidWorks would normally give you all kinds of nasty like file path errors if you did that. But when you're just starting to design something, or if you need to move this stuff around, it's really helpful to be able to do that. And then when you are satisfied with your virtual part, you can convert it to a real part, an externally saved part, or you can take in a part and make it virtual while it's in the assembly. So when you edit a part inside an assembly, let's say that you import something as normal, select edit part, what it's going to do is enter the part editor, but it'll still show you where that part is in the assembly. It'll show everything else grayed out. And you can actually use the assembly to define stuff in your part, even though it was created externally. So these are some things they're going to see in the demo, hopefully if the demo works correctly, because SolidWorks has been frustrating today. But that's some stuff I'm going to try to show you. So here's some more methods. These are the sketchy ones. I've written, they're a little more dangerous because they're sort of more difficult to work with and more unusual. Create an assembly from a layout sketch. You can make an entire assembly from one sketch. Basically, there's an option when you create an assembly to create a layout. You sketch all of your parts and export them as blocks, which is like kind of like a part or an assembly. It's a different file type within SolidWorks. And then when you have the blocks, you can link them together and move them as if they were 3D parts before you actually build them. And that's an interesting way, depending on what kind of thing you're working with. The other one, this is one I really like. Create an assembly from a part that's split into multiple pieces. Fusion 360 makes this really easy to do. It's not as easy in SolidWorks for sure, but it is possible. What it is you create one shape, which is kind of the outside contour of your part or of your assembly, and then you split it into all the multiple pieces that make it up. I'm going to show a little bit of this as well. And then exporting them correctly can be a little bit of a challenge. But helpfully, here's a bunch of video reference of how to do these things, because I do not have time to go over it in all of the detail because it can be quite complicated. But this will basically show you the process of how to do that. Here's an important note I wanted to add. You don't always have to do this. A lot of people say like top-down design is the best way to design anything. It's not true. It really depends on what you're trying to design, and also just how much time and effort you want to put into it, because doing it this way is more difficult in a lot of cases. It takes a lot of time to add in the equations. If there's a lot of parts in your assembly and you're editing them all in context, it'll slow it down because it has to load all of those different files. And if you're working with a team, which we mentioned earlier, it is even more difficult. So it really requires a lot of communication. And just in general, only makes sense for things where you know parts have to be defined according to other parts in your assembly. And generally, equations are good when you know those distances and dimensions are going to change. If your dimensions are well defined, you probably don't need to add equations. So yeah, be aware of these, because I think knowing about them can make you a better CAD designer, but don't feel like you have to do this.
All right. So here are some tips and tricks that we recommend for SolidWorks. Copy with mates allows you to copy a part along with all of its mates so that you don't have to import a part and redefine all the mates again. It could be helpful for something, say, like screws in a hole. You could do copy with mates and put a concentric mate along with a coincident mate all in one step. Construction geometry is very helpful. You could define planes and axes to a part so that you could mate it differently. In a part or assembly, in the feature tree, you could create construction geometry through a little tab. Things like planes of symmetry or important axes. You can also add physical sensors to a tree so that it could detect a property of a part. So let's say the mass or the volume of a part passes a certain threshold that you kind of set, it'll tell you so that you don't end up making a design change that you didn't intend to. And Sketch Expert is a really helpful tool to find an error if you have a broken sketch.
Yeah, and I'd suggest looking up any of these things separately because it's best to have a visual sense of how to do them. It's hard to put it just in words.
And earlier we were talking about how shortcuts are really important. And I cannot stress enough, like if you're CADing for 3 or 4 or 5 hours, you want to use as many shortcuts as possible. It'll just streamline how you CAD, and it really reduces a lot of time you have to spend when you like go into different tabs of a feature tree. So in that link, you can see some SolidWorks keyboard shortcuts, and here's some of the more helpful ones that might be of use to you guys. So the S key brings up a menu of shortcuts next to mouse. You could customize the shortcuts in that menu, but I think the default is you could view different panes for a sketch part of assembly. The D key brings up breadcrumbs. So you could press D on a feature to show kind of the steps that led up to that feature. You could edit a sketch or a feature or other things with the D key. Tab and Shift tab are used to hide and show parts. So if you're in an assembly, I also think it works in a part as well. But if you're in assembly, you could just press tab when your mouse cursor is hovering over a part to hide it. It's just really helpful if you're trying to hide a bunch of things and you don't have to right click and press hide manually. And keep in mind that you could customize all these shortcuts. So for me, I customized like mate to Z, measure to Q. Basically, I just put everything in one side of the keyboard so that I never have to move around the keyboard to reach a feature. But definitely use shortcuts. They're very important, I think, and it makes you more fluent in using SolidWorks. And I don't know, it just saves a bunch of time.
All right, so I'm gonna show you a demo of how some of this stuff works, specifically top-down design. And I've got a little example worked up so that I can show some of these things. All right, so give me just a second to get things set up. All right, so here we are in SolidWorks, and it's probably going to look really slow, and it looks like that for me too, because it has been a struggle. This demo should take about 20 to 30 minutes, and it's just a brief overview of some stuff. So the first example I'm going to bring up is actually the robot head itself, because this was one of the first things that I tried to design with top-down design in mind, and it was, I would say, a mixed success. But I'm going to show you some of the things that I did. So when you're taking a look at this design, you can see really quickly that a lot of these parts fit together, and they have to fit together really exactly. So basically, this would be very hard to design if I was doing all these individual parts. So I can show is I can hide some of this stuff using the tab key, very helpful. And you can see sort of how complex some of these interactions are between parts and how many lines they share. So if you were designing this normally, it would be very, very difficult. And if at any point you had to edit it, it would be just basically impossible. So how I did this, because this is an assembly, right? These are all parts that are in here. So I had this other file. This is the skull prototype file. And this is basically, it's a part file. So this is one part. And how this worked is I started with one shape and I split it. So this is that thing I was talking about earlier. So here's a tip. I don't know if people know about the feature tree and how you can scroll back history. So I'm doing is I'm taking my mouse and I'm going to scroll back. I can show you a little bit how this was built. So if I just drag and drop that line between any feature, you can see what the design looked like at that point. So at one point, this is what it looked like, right? It was one shape that I built up, and then I made a shell of it, because that's essentially what this head has to be. And then from that point, I moved forward and I did all these other things. So I split it vertically and horizontally. I added these cutouts because the flat panels go here. And then as I went, I just built up all of those complicated interactions by essentially creating split lines and then splitting this body. So the end result is you can see most of the parts that are present on the assembly. And they all fit together because they're built from one part. So if I update that part, it'll update everything I did since. So since it's one part, what you want to look at is this folder called solid bodies. So if I go in here, you can see that every time I did a split, it created different bodies. So it detected which pieces were separate from the main body. And then a couple of them I hid, like there's a top panel and a back panel. I hid them just so I could see stuff. But basically each one of these I can export and I can make it as a part. I think it's insert into new part, creates a new part that just has that in it. And it also maintains its dependence on this original file. So if I went back and I changed this, that like this bottom corner part would update, and also the assembly would update. So it's still a little bit sketchy, like absolutely some things that it just has a problem with. Every so often when I was working on it, I'd create an edit that the assembly didn't want to update. So I would have to go in and export all these bodies again. But like it still worked pretty well. And again, would have been nearly impossible to create if I was creating these as separate parts. Okay, so that's one method, the split method, which I like, but I'm going to show a more common method. We're going to not change these saves, not change these saves, not save these changes. So it's, yeah, it gives me messages like this all the time because it's saying, do I want to keep changes? Let's just discard changes because I'm not going to save the assembly either. I just opened it to check this out. It's going to take a minute to close off because Solidworks has anger issues. It's going to work on it, so bear with me. Anyone who's watching, let me know if you have questions about anything at any point, because there will be a little bit of downtime.
Yeah, SolidWorks needs therapy.
Yeah. Oh, it's working on it. Okay, here we go. So here's my assembly. I'm just going to close that too. Don't save. And give that a minute. Okay. So the next thing we're going to do is we're going to make a box. And a box is a very simple thing to make. And I chose a box because I wanted to not take up too much time. And eventually we're going to put this handle in the box. But first, let's make assembly. It's going to take a minute to think about that, to really process it. Okay. So here's our begin assembly screen. I could choose parts to put in here. That's usually how you start an assembly, is you choose one part to put in. But I'm just going to hit a check mark and I'm going to just have nothing at all. So I'm going to gather my thoughts here and I'm going to think, what am I doing? I'm making a box. And what I'm going to do is I'm going to define the dimensions, the global dimensions of that box before I start doing anything. So let's go up here, tools, equations. That's where it lives here. It'll also live over here eventually. So here's equations, and this is where I can type in global variables, and then some stuff will get inserted here automatically as I use the variables. But real fast, let's just type in a couple of random numbers. All right, let's do width. Oop, what happened? It's gone. Let's try again. All right, interesting. Width, length. Let's do 5. Height. Let's do 2. The other things I'm going to need are wall thickness. It's a good one to have. Let's do 0.25. And the last thing is corner radius. Let's do 0.25. So these are pretty basic. And if I had a more defined design, I would have numbers that I'd be working from. I'm just going to hit OK. So now the equations live over here. I can take a look at them and I can see all of these. I could also define equations in terms of other equations. If I wanted to say that at all points the length of this box will be twice its width, I could have typed in width times 2, and that would automatically update if I ever changed the width. But for now, let's just keep these as numbers. All right, so now I'm going to make the first part. So I'm going to go insert components, choose new part, And I can actually create a new subassembly inside this assembly if I wanted to, but that's too much for my brain. So here's a new part, and just click to select that. Okay, so here's a part. It automatically creates fixed, and then the name of it shows up in these brackets. And that means that it's a virtual part, which is what I described earlier. So it's a part that exists only inside this assembly, which is indicated by a little bit of the syntax, how it has a caret and then it says assemb1. So it's a part that exists only in here. And if I go down, I can see that it has all the things in it that a part would normally have, right? It's got a copy of its own history. It has its own equations, actually. You can give it its own equations, but I'm going to skip that. And basically, you can create anything in here you could in a normal part. So if I click on that and I go edit part, it turns blue. It shows me it's being edited. And then I can start building it. So what I'm going to do is show the origin planes so I can sketch on the top plane. All right, so here we are. Very basic box making now. Let's just grab a center rectangle, create that like so. I hope this is showing up all right for everyone.
Yeah, it's not laggy at all.
Okay, good. So I selected Smart Dimension here, and I'm gonna grab one side and dimension it. And then I'm gonna do an interesting thing here, where I'm going to try to pull that equation that I created earlier. So I'm gonna hit equals. And equals allows me to select a bunch of stuff. It's basically saying whenever I type equals, I'm gonna link that dimension to the next thing that I type in, and it's gonna update when that thing updates. So what's really annoying is that it doesn't show me the assembly equations here, but I can get to them if I go to this feature tree here, go to the equations for the assembly, and I'm gonna select width. So you can see that it put it in the dimension box with this weird syntax where it's telling me that it's width, which is part of the assembly dimensions. That's just how that's going to look. But if I hit enter, here it is, it's set it to 4. And this little sigma here is telling me that it's a linked equation, that it's not just I typed the number 4, it's linked to something which is telling it to be 4. So let's do that again. And SolidWorks really slows down when I add the dimensions for some reason. It likes to do that. So set equals again. Grab the length. And when it processes that, there we have the profile of our box. All right, moving right along to features. There's one more important thing for this box, which is going to be the height. Oh boy, the speed is good. So I can even type an assembly or an equation into here. If I type equals, it'll give me a lot of the similar options. You can go up there and equations. And here's everything in the feature tree that I can select as well. Let's select height, puts it in there, and then I have a box extrude. All right, successfully made a box. And I'm gonna hide these. So that looks all well and good. I'm gonna do my last operation, which is just to shell that. So just select the face I want to shell. And then I would type in a thickness here. When I tried doing this earlier with the dimension, didn't work for some reason. Not every box you can type assemblies into. So I'm just gonna leave it like that. It's a little bit annoying, but if I do that and then I hit edit, it'll let me do it. So who knows why. So now I'm going to type equals and then I'm going to do wall thickness. Oop. Wall thickness. Can you do it? There we go. It might have done it twice. Nope, there we go. So that looks pretty good for a box. So, but I could have done any of that in its own part, right? So the real strength of this comes when I have multiple parts interacting. So I'm gonna rebuild real fast. It's good to just rebuild whenever you see that traffic light thing come on. You go up here and you click rebuild, because generally it will fix issues that are currently happening. If something happens and you're like, why would it have that problem? It's probably just the software bugging out. You just rebuild and it'll like fix a lot of stuff. So I'm going to stop editing this component by deselecting that. And now I'm back in my assembly view. So let's create another component. New part. Creates it much the same as the other one. I'm going to go edit this part. And now it grays out the rest of the assembly. So it's showing me here's where everything else is, but you're not editing that right now. You're just editing its own part. So if I sketch, I can sketch on this face itself. I just want to make a lid for the box. I'm just going to make a really simple lid. So what I could do now is I could go in and I could define all of those dimensions again, right? Because I have equations for them. So I could do that. But basically I know that the lid always has to fit that box. And I have this profile of the box available right here. Not offset, oops, convert entities. If I click convert, and I just grab these profiles, it turns those lines into my sketch. So it's not so impressive if it's just a square, but imagine if I had some really complicated shape that I was making this box. I wouldn't want to define that box again. I would want to basically copy over that profile. And it would be even worse if I had a 3D contour. And what I could do is define one contour in terms of another so that I don't have to try and recreate a 3D geometry so that the parts fit together. So that was very simple. Let's just create an extrude. Try to just select both of these. Sometimes it doesn't select the right contours. Like, I don't know what all these colors mean. It just turns so many colors when I click on it. I don't, anyway. Hopefully that'll do it. If not, I can go in and try it again. Distance is going to be that wall thickness. So let's grab that. There's probably a shortcut to getting to these as well. But it's good to know where everything is. Okay, yeah, so it looks like it just made that part, which is a little bit annoying. Let's see if I can, oh, that's the wrong part. Let's go back in here, grab that sketch again, create another extrude, and just select the inner contour. It's sort of been constantly having a struggle with that. I'm supposed to be able to go into selected contours here and like really, there we go, that's what I want. Equals wall thickness. Okay, sorry about that. So we've got our two parts, and what you'll notice is that each of those dimensions, length, width, and height that I needed, I only had to type it in ever once. Everything else, I just defined it in terms of what was already existing. So let's rebuild this and exit, and then I'll show you sort of how nice it is now to go right click on, nope, not that one, the assembly equations, right click on them, manage equations, and say I don't like the look of this box. I'm like, it needs to be taller. We just need a tall, very, very tall box. And we also need a very wide box. I can hit OK. And anywhere where I would have defined those dimensions, I don't have to redefine them because it already updated it, and the lid still fits on top. It's great. It's so convenient. Another thing that's helpful is you can create assembly features. You can create a feature that affects both of these parts. I just discovered this kind of by accident because I was like trying to do this. If I go to fillet, I can fillet these edges together. I can click on that. I can just click on all the parts that I want filleted, and it'll do it in one operation. It'll do it with the same dimension, and it'll affect both parts. So there are better options to select fillets. There's some, yeah, there's tangent propagation, I think, is one where it detects. So it's on, but it's not getting all the edges. So I'm just going to manually select those.
Yeah, sometimes you don't need to manually select. I don't know when, but for some,
yeah, it does it sometimes.
you could, yeah, they could do it automatically for you.
But. Yeah. So I'm filleting that, and what am I going to fill it by? Of course, I'm going to use the equation corner radius, which lives here. Yeah, there we go. Nice. So it's the whole thickness of this lid here. All right, so this box is great. Both parts are fixed in position right now, which isn't ideal. What I want to do is float them and then mate them to each other using the coincident mate and all that so that they actually work together. I'm going to skip that for now because it's a pretty basic operation. But what I want to do is basically show you how this interacts with a part that already exists that I want to put in here. So let's do insert components. And this time, let's insert a component that's external. Let's insert this handle. So here's my handle. And here it goes. And as you can see, it looks great, but it doesn't really fit this box super well. But I already made the handle, so what am I supposed to do about it? Well, I can show you that. You can actually edit what this handle looks like within the context of the assembly, even though I made it outside the assembly. So the first thing I'm going to do, I'm going to add a couple of mates really quick, just to make it look better. One of my favorite mates is actually under advanced mates, and it's width. Here, wait, I selected that by accident. Width mate, if I select that, it needs 4 inputs. It needs sort of 2 edges. So I'm going to do the symmetrical outer edges of this. And then it needs 2 more edges on the thing that it's making symmetric in width. So if I select those 2 edges, you can see that it's always, they're midpoints of those, basically the midplanes of those sets of planes are always going to be aligned. So you can see what that looks like. I'm sort of moving this around. Well, it doesn't look very good from there, but it'll always, from the top, be symmetric. So let's add one more on the other side so that it's in the middle.
You'll find that you'll use width a lot, or it comes in handy a lot when you're dealing with symmetric assemblies.
Oh, I did that. Selected them wrong. I want to grab one here and then the other side, and then these 2. All right. And last, let's do a coincident for those 2 planes. All right. So it's not great for this box because it's a bit too wide. So I want to change a dimension in this handle so that it fits the box. And there are a couple ways to do it. Basically, I just go into my handle and I hit edit part. I could hit open part and that would show it in its own window, but I want to hit edit. The assembly must be saved. So when I try to do this, it's like you're getting a little bit serious and it wants me to make sure that I'm sure before I move on. This is pretty normal. I'm just going to save this as just a box to my desktop. Okay, so here, this is an important window. It's saying save without in-context references or save with in-context references. So it's saying you're about to edit this handle, which you have in a separate file. Do you want to edit your original file when you change the handle, or do you want to change the handle only in this assembly without changing my original? So let's say that I want to make this handle fit the box and I want it to update, then I would do with in-context references. All right, so I'm just going to save that. It needs to know that before it edits the handle, which is why it makes me save. It's a little bit annoying, but there we go. It did it. Okay. So now I can edit part. And I can see the whole assembly is there, but I'm only looking at the handle. And I can see everything in the handle and here, the operations I used to make it. I could just go in and edit them directly. A really easy way to do it is double click on the part and you can see the dimensions that made all those features. And I can actually edit these directly. So if I double click on this width 3, it's going to think about it for a good long while. And then let's set this in context of the assembly. So let's set this equal to, firstly, width. I believe, did I make width longer than, I don't remember which one's width, but.
Width is the longer one.
Width is the longer one right now? Okay, so I want to set it to length, right? Because I want to keep it so that it's not too wide. So I'll grab length, and then I'm going to just do length minus 2 inches. We'll give it a good margin. Okay. It's going to think. Let me rebuild it. It looks like it didn't do it. I think it might be width, not length, that I need to update. Let me try it one more time. Because I think width or length is set to 5 right now, and width is set to 7. So it should be in terms of, or no, which one? One of them is 5. One of them is 7. Basically, I just want to delete that. Let's try doing it again. Let's do width minus 3 to see if that works. Yeah, it's having difficulty with that. But anyway, here, this one needs to rebuild. Try rebuilding that. That'll do it. Okay. Yeah, you can see that it widened it. So I do have my length and width mixed up. I think 2 maybe just wasn't enough of a margin, but you can see that it changed the dimension, even if it's not exactly what I want my box to look like. I'm gonna leave it as it is for now, just because you can see the effect that it had, where what I was hoping to do is if I made this wider or shorter, it would change the length of the handle so that it is inside but not too small. So it would be approximately the width of the box. So that's what that looks like. And I have an idea that if we edit this, it's going to look even wonkier because the width and length are set backwards. So let's just set them equal to each other so that we can see the effect. Let's set them both equal to, yeah, equal to 5. And then let's change some of the other stuff. Let's change the corner radius down because it's blocking our view of the top there. There we go. That's interesting. Width and length are equal right now, but they're not. So that's just some of the little struggles that come up. I don't know why that's doing that.
You'll find that Solidworks doesn't work as expected.
It doesn't solid work, if you know what I mean. Yeah, that's really interesting because I definitely set those boxes originally and they're now set to the same size and they're clearly not the same size. So very interesting. Yeah. I did practice this demo a couple times and it worked. So if this happens, you just have to do some troubleshooting and figure out why it's not doing that. But you can see that the size of the handle is updating. And if I go here, because I told it to update, the handle is updated here. You can tell that it's much shorter than it started. And the dimension actually inside this part references the assembly, which can get real screwy if you ever do something like delete the assembly. So you do want to be careful about that. But anyway, all right. The last thing that I'm going to show is something that always boggles me, which is configurations. The equations actually work really well with configurations because if you've ever worked with configurations, you know how difficult it is to edit something and make sure that you're editing it in the right configuration. So I'm going to create a little configuration called box 2. It's going to do that. Go back to my main stuff. Everything looks the same because they're duplicates right now. So let's manage our equations. And then I can change these only for one configuration. So here it's showing me which configuration I'm in. But changing it won't actually do it. What I have to do is click on this and then a window shows up that's previously invisible, which is how amazing SolidWorks is at hiding the configuration menus. Is it doesn't even show up until you click. So I'm going to change it from all configurations to this configuration. And I'm just going to change these two or these three variables, and I'll just change them to something else. Just make height kind of big. Maybe this will update it, maybe it won't. Height hopefully shouldn't be corrupted yet. So let's just leave it at that and see what it looks like. All right, it looks the same, which is interesting. It seemed to have lost the ability to tell what the equations are at all. It's not super thrilling, and I think as expected, the configurations both look the same. But the idea is there. I don't know.
Usually it changed, but
usually it changes. Somehow the links broke at some point. Maybe they broke when I saved the assembly. Because like, I should be able to go back in here and see that it's still referencing them. Like if I edit this part, I can see how it was built. And I can see that I use those dimensions. Like here's my sketch. You can view it and it's showing me that, you know, those equations are making it 5 and 7, which currently is not the value of this. So I don't know why I did that. But I definitely did it before and it worked. So take that as you will. I don't know if this is a very convincing advertisement for top-down design. It's much easier in Fusion if you know how to use Fusion. But I really tried to make it work in SolidWorks, and maybe it just is not the thing. But I'd encourage anyone to play around with this, see if you can get it to work, see if there's something I'm missing. Yeah, I really don't know. Interesting. But it did work before. All right, that's pretty much the end of the demo. It was a bit of a flop on the top-down design portion, but that's all I got for you on that. So there's a couple more slides in the presentation if we want to take a look at those. All right. So that was the demo. And here's a couple more things.
Yeah, if you guys want to learn more on your own time, the video that we linked is really, really helpful. And as always, like the internet's your best friend. So SolidWorks has help pages, have forums, and they kind of help you on. If you have a problem, you'll probably find it in the SolidWorks help pages, especially with top-down design. As mentioned before, the videos are pretty helpful. YouTube has a lot of SolidWorks tutorials in general. And yeah, Google is also your best friend. A lot of the stuff that I didn't know about SolidWorks, I think Rebecca as well, we learned from Google. So
For sure. Yeah. Yeah, I highly recommend that first video. It's a lot of the things I mentioned, but actually shown, and they look great. So yeah. All right. And as always, upcoming ASME information. I've got a bunch of really cool events coming up: speed friending, Cards Against Humanity, resume and pitch workshop for professional development, and then looking to next week, we're going to have Among Us night. So all of those are going to be great events to attend. You can find more info in the newsletter, and I think most of them are going to be on Discord. So
yeah.
that's great.
And, if you guys are still looking for an internship, or if you guys just want to polish up on your elevator pitches or your resume, that resume and pitch workshop is going to be really helpful. So I highly encourage you all to go.
Yeah. And as always, you can contact us. You can ask us any questions, all of that. And that is all we have for you. So thanks everyone for coming. Let us know any questions you have. I'm going to stop the recording.